Okay, folks, I think we're going to get started. It's just 20 past 10. So thank you for those that have come back. So this is the second part of the oral session for space weather forecasting, science, operations, future missions, missing information, and the economic case. We've already had the poster session, as you know, yesterday, and some good oral talks this morning. And we now move on to short oral talks followed by a panel session. So each panelist is going to come up, give the talk, go back, sit back down, and after all the panelists have spoken, we'll ask you all to come up and join us on the podium, and Auntie will take over then with the questioning. The panelists were asked ahead of time in their summary slide or summary 2 slides to address the question around the ideas of, since space weather has received significantly elevated high-level attention over the last few years, and the examples we gave were the US federal government, in terms of the National Space Weather Strategy, and also the continuation of space weather being on the National Risk Register in the UK. What else could we do as a community to make the case for space weather even stronger that we're not doing already, or that we're not doing well enough? So hopefully the panelists have remembered to take that into account when they give this summary. And we're going to have all 6 panelists speak first, and then they'll all come back on the stage. So let's start with the NSS perspective on space weather research for building, forecasting, and capabilities by Irfan Azeem, please. Thank you.
Well, thank you, Mario, and Auntie, for inviting us to give a talk on NSF's effort to promote space weather research in support of building forecast capabilities. I'm Irfan Azeem. I'm the Program Director for Space Weather Research at the National Science Foundation within the Division of Atmospheric and Geospace Sciences. Just looking at the audience, looks like most of you know who we are, what we do, but for those of you who haven't had the opportunity to work with NSF, let me point or make a couple of remarks. NSF supports fundamental research in science, in all this, fields of science and engineering. And also we support education in STEM discipline. NSF, unlike other federal agencies like NOAA and NASA, does not operate its own research labs, and it does not do in-house research. We support scientists and engineers and students through their home institution, whether that's in academia, private sector, or other government agencies. I don't have to tell you, the audience, that why space weather is important, but the note I want to make here is that the reason why NSF supports space weather is that we recognize that preparing the nation for space weather, and whether that's via developing resilience for our critical infrastructure or developing forecast capabilities, requires a strong commitment to basic research to further our understanding of the space environment, which then allows us to develop more comprehensive and more accurate predictive models that require that requires advancement of state-of-the-art in instrumentation and measurement techniques, and also that can allow us to, or that requires creative utilization of measurement assets both on ground and in space in a manner that they would support, or they will complement each other to provide us key insights into space weather events and how they are formed, how they propagate, and how they evolve over time, and also in space. And taken collectively, then we can, all of these activities, then that would allow us to address some of the key questions, like how does space weather impact systems, whether they're in space or on ground? How does the space weather events affect our economies? How does the space weather pose a risk to human health? And how does the space weather disrupt our preparedness for our national security. NSF supports space weather research by engaging in three main activities. First is advancing fundamental knowledge by addressing key science questions in space weather. Second is education for next generation scientists and engineers in space weather. And then thirdly, we partner with the key stakeholders in the space weather enterprise to transition knowledge that's born out of space, or born out of NSF-funded research to address societal needs. This is a slide from Tomasz and Bisi that kind of illustrates the complexity that is we face when it comes to space weather forecasting. So if you look at the space, the entire domain from sun to earth that contributes to space weather, it is truly a multi-scale and a multi-physics problem. So you have systems that are characterized by multi-scales both temporally and spatially. And then you also have systems that exhibit the multi-physics from kinetic physics to MHD. So that our ability to nowcast and forecast space weather requires a fundamental understanding of this system of systems that is multi-scale and multi-physics. So now that I've mentioned that this space weather forecasting is a challenging effort because of the complexity and as I mentioned earlier, what do we need to build better space weather forecasting capabilities? We need advanced numerical models and data simulation models. When we input or develop new physics into the model, we need observations. We need to validate model outputs so against observations. And we also need observations to ingest into our data simulations models. And those global observations can come from space or air or land and also even ocean-based. So I think it's about time that we need to really start thinking about how we can go beyond just the ground-based and space-based observations and also start deploying sensors in the oceanic region. Over the last 5 years, the technology in the remotely piloted marine vehicles has come a long way. And now the new unmanned marine vehicles can support multiple sensors and then provide the capability of getting the data in real time. So that's something that we need to start looking into. Then we also need to do capacity building. Space weather is a data-starved discipline. We certainly need more data to go into our models, into our data simulation models. Just taking the example of ionosphere thermosphere, there are regions that are where there is a severe paucity of data. So we certainly need new observations in those data-starved regions. We need to develop national and international collaborations to coordinate efforts for space weather capability and information sharing. NSF-funded SuperDART is a great example of international cooperation and coordination. And we also need to develop new generation of forecasters or space weather forecasters. And I can foresee that if space travel becomes available, it may not be widely available, but it could be something like, flying from New York to London on a Concorde. Safety will be paramount, so we need to have a new cadre of space weather forecasters. So let me just quickly point to some ongoing efforts at NASA or at NSF to support space weather research. So this is a NASA and NSF joint effort to develop strategic capability in space weather modeling efforts. We have CME flare and CME initiation and propagation. And then we also have this Prevents Awards. We just recently had 2 Prevents Awards made to Michigan, and there will be a next competition in fall or summer or fall of this year. NSF also supports observation into all aspects of space weather, whether they're on the sun. We have the Mauna Loa Solar Observatory, DKIS, which is the Daniel K. NOAA's solar telescope that's being currently built in Hawaii, and that we're going to see first light later this year or early next year, or later in 2018 or early 2019. And we also operate chains of magnetometers, Ampere, and then over on Iridium constellation. NSF also funds SuperDARN sites and several encoding and scatter radar sites. So Mario mentioned that he wanted the speakers to address how to make the case for space weather stronger. So let me just kind of conclude my talk by just making some remarks about that. So one of the things we really need to do is engage the end user, whether the end user is a satellite operator or a warfighter with a GPS positioning device, or it could be a farmer utilizing precision agriculture. We need to engage the end user and demonstrate the system impact that affects their operations. And then we also need to do a good job or better job in transitioning research and transitioning that to operators who can then provide useful information to those end users. And then we have done a fairly good job in addressing these low frequency, high impact events, but we really need to address day-to-day variability in space or in space weather. Just like terrestrial weather, space weather happens every day. Just let me quickly display these two movies. The top movie is a variability in the ionosphere. Is the variation in TEC or bandpass filter TEC that shows a lot of variability that's generated by convective storm in the troposphere. And at the bottom, you can see there's other sources of variability in the ionospheric space weather. So this is the SpaceX launch from Vandenberg Air Force Base, and you see large variability. So we've come a long way since the first strategic plan was under National Space Weather Program was published in 1995, but there's still a lot of work to be done. There's a Space News article that says researchers bemoans limited space weather prediction capabilities, and NSF is committed to funding the best science that's going to push the envelope or the frontier of space weather research forward, and will support a space weather community to develop predictive capability for space weather events, whether it's extreme or non-extreme. Thank you.
So we're going to save all the questions for when we have all the panelists together. So next we have Towards a Global Hub and a Network for Collaborative Advancing of Space Weather Predictive Capabilities by Masha Kuznetsova.
So many of you know me as a CCMC director, but today I'm putting my another hat that I recently got as the chair of panel on space weather in COSPAR. And this presentation is done together with my co-chairs and liaisons. About 2 years ago, the Global Space Weather Roadmap, commissioned by COSPAR and International Living with the Star program, have been published. And the roadmap contains a number of recommendations and priorities, how we should move forward with modeling capability, our understanding, observation capability. It's contained feasibility analysis, priority analysis, offers some pathways that we take to address the needs of operations of end users. But what I want to focus today is just on general recommendation that sort of summarize the main issues, the main challenges that we have now. So the main challenge is to understand and learn how to quantify key aspects of space weather. Phenomena and physical processes originating in the sun that are propagating through our ambient heliosphere and finally impacting geospace and impacting technology and actually having economical impact on society. Another is address so-called R2O, research to operation challenge, that basically mean established best possible mechanism of rapid implementation of latest advances in understanding, observation, modeling, and research in the space weather applications and operations. And the last, most important, is that we need to transform to effectively functioning, operating, information sharing global space weather community. And on Monday, Thomas Zurbuchen actually put it very short, referring to how NASA Space Mission Directorate should behave. We should work like one. And I think it is short and clear, and that's what we need to do globally. And in my presentation, mostly addressed this research to operation and also the last point about how we will move towards the global community. So, the research to operation, it of course should exist in any fields, but it's some very prominent in the field of space weather. So I just decided to take a look what factors feed into this, challenge. And, everybody saw this, bridge between research and operation. But if you start looking just on the term of space weather, we found there is some already in the term of space weather that feed into that. So because the space part is actually the field of heliophysics, by the weather, the field of meteorology. But on the other hand, heliophysics mostly traditionally focus on fundamental research, and there are no really funding opportunity in culture that have applied research component by meteorology and actually even space science have that applied research. So the weather community, World Meteorological Organization, and NOAA and the Met Office and other took the lead in providing operation services, but that's lead to this gap because the research, contrary to meteorology, actually done in different field. And it's also come that space weather is multidisciplinary already field, and it was already mentioned today that we don't have really opportunity for representatives from different disciplines to work together. So our community, like GEMC, they shine in the US, they're not really inviting very much to mission engineers or infrastructure engineers, and they are not really willing to come. We sometimes, having this meeting with alternative monologue, but that's it. There is not much opportunity to work together, and that's the only way how we start understanding each other and really move forward. And there is other, lack of coordination. Like for example, to advance research, we need rapid implementation. We need to test how new capability work. But on the other hand, there is a robustness requirement in operation. So rapid implementation is not, so there is some need to be middle stages. Again, there is mismatch between finding opportunity and recognition that things are important and action plan, even national and international. And there is also, we have competition, but it's somewhat pushing things in opposite direction. That's what we need to do, partnership and sharing. So there are forces that bringing us apart, and we need sort of to bring other forces that bringing us together, and they should be stronger. Then, all these gaps will disappear. And just a few words about, this research to operation. Again, it's usually referred like a bridge or a two-way highway, R2O to ROL loop, which imply that there is two entities. Research and operation is like a border. What we need is actually space weather without border. It's not only internationally, but within the field. We need to work together. So we sort of, with my co-authors, we come up with this idea, space weather, dartboard or shooting target. And it's the green is like research, and the red it's operational services, and the yellow is transition. And it shouldn't be really sharp border there, but it's give a right place for operations, because from point of view of investment, what we need to investing operations not that expensive, but they are very important, so they are not that big. But that's our goal, that's what we want to improve. But a lot of investment is going into research, understanding, modeling, observations. And the important element is all these errors, so it's really multi-way interconnection, it's just not one loop. And so that's sort of a sketch how our vision should be. Another, look now focusing on that, working as one. And traditionally, really, we have a top-down approach to advancing space weather capability, at least internationally. So there is in the center, you see this box, and I try to put logos on most international space weather stakeholders. Of course, I now put COSPAR in the center, but COSPAR is this space, organization research. But then there is also national agencies, and all of them produce, policies, statement of guidance, reports, action plans, of course, this roadmap, but they're very similar in some aspects, because a lot of maybe the same people are working, but they are not aligned. And what's important, they are not aligned with funding opportunities. And then there is, space weather workforce. It's actually researchers, scientists, students, model providers, all people who they are needed. Without us, there is no realization of recommendation. So there is more need to have an opportunity to unite and somehow to organize this bottom-up component. So that's the idea that panel of space weather want to pursue, is actually organize this international space weather action team that will be a hub for realization of roadmap goals and national action items, plans, and joint force to accelerate progress and maximize return on investment. So I think I will not go in the details of that teams, but we have some precursor of that. It's already, we organized this thanks to request of Living with the Star and CCMC help here. We organized International Forum on Space Weather Capability Assessment that we're planning to use as precursor what we want to do internationally. But my last answer to questions, what we need to do, to make it short, so space weather is global threat, and understanding, predicting space weather, understanding economical impact, that is global challenge. So we need to unite, and we need to join these SWAT teams. So thank you.
So next we have Global Space Weather Observational Network, Challenges and China's Contribution by Wang.
Good morning. I'm going to talk about Global Space Weather Observational Network, the challenges and the China's contribution. As mentioned in the previous speakers, the space weather is a multi-scale phenomenon covering from the solar atmosphere to Earth. We need to understand the solar and Earth connection, and also the observational challenges lie in two aspects. One is the micro scale. We need to understand the basic space physics process, like the magnetic reflection and the acceleration of particles, and also the interaction of the neutral particles with charged particles. And also, we pay attention to the micro scale. We need to understand the energy released in the solar atmosphere, the transfer from the sun to Earth, and the dissipation in Earth. Also need to understand the space weather cause and effect chain. So in this way, we need multiple observation means, including the space missions and the ground space observations, to make simultaneously observations from the sun to Earth. Then I would like to mention the China's contribution, both from the space weather science missions or ground-based project. Also, we proposed a IMCP, the International Meridian Cycloplane. The first space weather science mission, I would like to introduce you the SMILE mission. This is the solar wind magnetosphere ionosphere link explorer, which is a new mission to image the magnetosphere. When the high-state charged particles from the solar wind in charge exchanged with the neutral atoms from the Earth, then they will emit the soft X-ray emissions. In this way, by taking the soft X-ray picture of the Earth, we can understand the movement of the cusp region, the magnetosheaths. So we will send a small satellite into a high elliptical orbit with the perigee about 5,000 kilometers, and the apogee is about 19 Earth radius. In this way, we can take this global picture of the magnetosheath and the cusp region, and in the same time, we will take the picture of the lost aurora. Then we can establish the link between the magnetopods, cusp region, and the ionosphere. The payload on board SMILE missions, including the soft X-ray imager and the ultraviolet imager to take the polar aurora, and also in situ measurement of the solar wind and the magnetosphere, including the plasma and the magnetosphere. And in this way, we can investigate the dynamical response of Earth's magnetosphere to the solar wind impact in a unique and a global manner. The second mission I would like to mention is we call the ASOS, the Advanced Spaceborne Solar Observatory. We will make the simultaneous observation of the solar flare, the coronal mass ejection, and the solar magnetic field. And this is a payload including the 4-disc vector micrograph, Gamma alpha solar telescope, and the hard X-ray imager. And the second mission in the geospace and the study is the MIT mission, is the magnetosphere, ionosphere, and the thermosphere covering exploration. We will send a spacecraft constellation consist of 2 satellites in the ionosphere and 2 satellites in the magnetosphere. Then we can investigate the outflow from the ionosphere to the magnetosphere. And this payload, including the particle and the magnetic field and the electronic field measurement. Both ASO and the MIT mission are in the phase A study. And then I will turn to the ground-based project. The first is the Chinese Meridian project. We employ about 15 stations, mainly along 120 degrees in longitude, and 5 stations along 30-degree loss. We have a geomagnetic field measurement and also the optical atmospheric measurement, including the LiDAR and FPI, and all kind of radar and the sounding rocket. This mission has kicked off in 2012, and then we will propose the second phase of the Meridian project. In addition to the 120-degree longitude and the 30-degree latitude, we added 2 more chains, including the 100-degree longitude and the 40-degree in latitude. Then we can cover all the landmass of the China, and also we have 4 key regions, including the polar region, the mid latitude, the low latitude, and also at Tibet plates. And the key instruments were employed in Meridian Project 2, including advanced modular incoherent scaling radar, multi-function LiDAR, and the shoot-down radar, and the solar radio heliograph. And the Meridian project sector phase has been approved recently, and we'll start the construction phase by the end of next year, and will be completely in about 2022. And finally, we proposed in international Meridian cycle play. We would like to propose to connect the 120-degree east and the 60-degree Meridian chains of ground-based monitors worldwide in order to provide a global picture of unfolding space weather events. And this space Meridian cycle will form a complete cycle of the Earth, and we can make the simultaneous observations in day and night, and we can make the comparison of the local and the global space weather events. To summarize, the space weather has received significantly high-level attention in China, and China will make a great contribution to the global space weather observation network in the next 5 years. And to understand the space weather need much more effort, which new missions are encouraged, and the international cooperation are very much demanded. And we would like to propose to form the Global Space Weather Monitoring Network and the Global Space Weather Information Network, and also the Global Space Weather Forecast Network to make a stronger case of space weather activities worldwide. Thank you very much.
Thank you, Chief. So next up we have overview of NASA heliophysics and the science of space weather by Elsayed Talaat.
Morning. Top one. Okay. So I just want to set the stage. NASA heliophysics is part of an integrated science program in the Science Mission Directorate, and space weather really cuts across all disciplines here. Heliophysics is the science of space weather. We do the physics, the fundamental physics investigations and research behind that, including missions and theoretical and data analysis programs as well. but the space weather, of course, is tied intimately to Earth science, as we found that recently that lower atmosphere effects are affecting our near-Earth environment, the ionosphere and thermosphere in particular. Planetary science, we've seen from the MAVEN spacecraft in particular how space weather affects the evolution of planets. And that has implications for the exoplanets, which in astrophysics as well, where the things we learned from space weather in near-Earth space and at Mars and Venus, we're applying to identifying zones of habitability in exoplanets. So heliophysics does this research. The strategic goal is to understand the sun, its interactions with the Earth, the solar system, the interstellar medium, including space weather. And it does this through what we roughly do 4 mission lines. 2 lines that deal with our more strategic flight programs, solar terrestrial probes, the Living with the Star program, which also includes a research element, and Living with Stars is the more applied aspect of heliophysics, and so it is more directly applicable to the near-term applications of space weather, for space weather, I should say. Explorer program, which is our competed mission line, our traditionally competed mission line. And we also have a robust research program that includes low-cost access to space with rockets, balloons, and CubeSats, as well as instrument development and the theory program, data analysis and modeling as well. So the motivation for SMD is fundamental understanding, provide the underlying science required to enable space weather forecasts. Our role is basically heliophysics. 1/3 of our program addresses space weather science. That's through the Living with the Star program, through its mission line there. Other missions that I'll briefly discuss that support the national space weather infrastructure, and international space weather infrastructure, and as you heard from Masha, the CCMC. And so we implement a research program for understanding the sun and its interaction with the Earth and the solar system. And as I said, missions are currently part of the space weather infrastructure. So we're also interested in the safe operations. NASA's also interested in space weather for the safe operations of its robotic and human missions using space weather research data and models. So this is kind of our family picture of the fleet of spacecraft we have, and I'll highlight a few: ACE, SOHO, Stereo, and Van Allen are actively used currently for as inputs to operational space weather activities by NOAA and other space weather prediction centers. But all of our missions, which range from Voyager out past the heliopause and the thermosphere ionosphere missions timed, address the science that we need to advance our knowledge of space weather in the solar system and in near-Earth space. Upcoming missions, we have GOLD and ICON, which are going to look at the thermosphere and ionosphere. GOLD in particular is going to be our first, it's a UV spectrograph that's going to fly on geostationary satellite on a host, as a host payload on a commercial satellite, the first for NASA. And it's going to give us 30-minute images of the upper atmosphere, so akin to a weather satellite, and we expect a kind of a revolutionary step that terrestrial weather has gotten from weather satellites to happen when we launch GOLD. And of course, you may have heard of the Parker Solar Probe and Solar Orbiter missions that are going to fly. Parker is going to fly into the corona, addressing the physics behind the acceleration of the solar wind and the heating of the corona, and Solar Orbiter that's going to complement that with a lot of imaging. So upcoming missions, I just want to point out that we are currently evaluating proposals for the Interstellar Mapping and Acceleration Probe, IMAP. which will fly, which we can say now will fly to L1. And we're also talking with NOAA in partnership to potentially partner with co-manifesting any vehicle or any investigation they want to send to L1 as well. And then we are formulating the Geospace Dynamics Constellation Science, Technology, and Definition team that's upcoming to look at the physics of the thermosphere and ionosphere. So as I mentioned, the Living with the Star is our main research arm beyond our missions for advancing space weather science. And it does this through targeted research program. Much of the main advancements through strategic capability, one of the main steps that we do strategic capability is through partnership with NSF. This slide here just lists the strategic science areas. I'm not going to go through them, but they closely align with the Space Weather Action Plan benchmark, benchmark activities that look at extreme space weather events that you'll hear about in a session tomorrow. We've had institutes that tie Living with Star research with the end users and other stakeholders. The one that completed recently is a very successful one, looking at geomagnetically induced currents. And we have two more that are currently in progress, as well as there was a solicitation came out for two new institutes coming up next year. I'll just point out that we have focused science topics in competition right now. We recently selected 3 focused science topics that were informed by the Space Weather Action Plan. And we have 4 more that are in competition right now. We've developed a new process of community input that would that is laid out here, and that that taken account with also the Space Weather Action Plan priorities is how we've selected the current set of focused science topics that are in progress right now. Step 1s were due last week, and the Step 2 proposals are due in February. And looking forward, just want to point out there's a town hall tonight, 6:30 to 8:45 in the Esplanade ballroom at the Meridian Hotel. We've reformulated the LWS Steer Committee into the LWS Program Analysis Group, excuse me. We've done that because we're getting in line more with FACA, the Federal Advisory Committee Act requirements for how NASA solicits advice. And I just want to point out that we have a couple of partnerships coming up with NSF and NOAA as well. So I think I'm out of time, so I will just end with this slide here, looking at the research R2O concept of operations that was agreed upon by the government agencies under the auspices of the Space Weather Action Plan. And it fundamental research, international cooperation, the drive centers, and LWS all feed into the CCMC, which is our interface with the operational community and end users there. So that's all we got. Thanks.
Thank you, Elsayed. So penultimate talk before the panel starts is the effort to increase the space weather forecasting accuracy in the Korean Space Weather Center by Choi.
Okay, in this presentation, my name is Choi from Korean Space Weather Centers. Actually, in this presentation, I will introduce our center's roles about the space weather forecasting and the recent R&D activity to increase the forecasting accuracy. Okay, this is content. First is our center's overview, and the second one, space weather forecast accuracy verification in our centers. And next, space weather cosmic radiation research to get the accuracy about our forecast. And finally, the summary. Okay, this is our centers, Korean Space Weather Center's missions. Actually, the research on the technology for receiving space radio waves and analysis of received data observation of geomagnetism and ionosphere. Next on observation of solar spots, analysis of the result observation. Finally, space weather forecast and warning services is our main role in our centers. Our centers, based on the observation data and analysis and prediction models, using this kind of data, we provide the 3-day forecast service to our customers. The customers are not only the general public, but also the industrial part. For example, the satellite, communication, defense, aviation, and power grid system company. Yes, this is some article about the Digest Act and the Radio Wave Act. According to the Digest Act, it defines in Korean the Republic of Korea defines the space weather risk definitely one of the disaster, and Korea Space Weather is managing this space weather disaster representative of Korea. And according to the Radio Wave Act, we have to prepare the base plan to manage the spatial risk. So based on these two acts, we have made standard manual for space weather risk on 2013. I'll skip this slide. Next one, most of people in here must be familiar with this picture. Anyway, there are 3 kinds of the solar event: electromagnetic waves, X-ray, cause the radio blackout in the Earth, and high energy particles, solar radiation storms, and coronal CME and geometric storm in Earth. In our centers, not only predict the solar activity and analyze the effect on Earth by this kind of solar activity. This shows the brief summary about our space weather forecast models for each solar event. First on the radio blackout and the solar radiation storm and geometric storm. ASAR, automatic solar synaptic analyzer models, is one of our representative models, which is a flare forecasting models. Actually, it is already registered in the CCMC. You can download and use it. Next one is the space weather effect analysis models, which are operated in our centers. For each industrial part, we manage separate models. For example, regarding the aviation, we have developed the SAFE model. The models calculate the cosmic radiation dose during the aviation flight, and we provide this information to our domestic cabin crew. Next one, space weather's forecast accuracy verification. Actually, this example of our forecasting format. Actually, we for each solar event, we classify with 2 groups: the lower level group and higher level group. So every day, our forecaster determine the probability which happens the solar event. But so far, the verification of solar prediction was not so good, because actually we just only used the probability method, and only in case of the solar event, R event, we have verified, and it is done by manually. So in this year, we would like to improve this kind of mechanism. So use the verification metrics, calculate based on the older metrics which are recommended by WMO. Actually, the method were developed for the terrestrial weathers. Anyway, we are going to adapt all the verification method and compare the result between the method, and we are going to find the very most suitable method to estimate the accuracy of our forecasting. Next one is space weather's cosmic radiation research in our Korean Space Weather Centers. Actually, the cosmic radiation are summation of the SEP by solar activity and the GCR, the galactic rays. As mentioned previous, we have developed a safe system. Actually, it is designed based on the NASA model. Actually, we just input flight time airline, then you can get the radiation dose over flight. Currently, we are going to verify the reliability of the safe systems based on the real measured data. Actually, we introduced two instruments to gather the actual measured data on space radiation dose in domestic flight route. This shows the result of a safe system. This one is one of our instruments to measure the cosmic radiation dose, actually. This is a specification of this instrument. And next one is the others, almost FM5 instrument. This shows the measured result, which we have done the last May 5th, from Seattle to Incheon to Seoul. Actually, you can see the almost effective dose rate and our prediction model, the NARIAS result. This is another one which was measured on June 10. You can see that generally the cosmic radiation is lower comparing to the previous one. And this is a result by our Meridian device. Actually, based on this kind of measured data prediction result, we are providing the radiation analysis, result through web service in our homepage. So you can see the radiation combination result and the radiation distribution maps, such like this. Next one, I would like to introduce some ground-based neutron monitor in Korea. Actually, neutron monitor, as you know, measure the high energy particles in the atmosphere. Actually, it is high correlation with the solar activities. This is a picture of the. Yes, it is captured image, which was captured in the 2005 October 20. Actually, there was some SPE event, and you can see that there was a 2 published decrease and 1 ground level enhancement GLE. So the second image shows the proton flux, which was captured, provided by the GOES satellite, and the third one is the neutron monitor data. So you can see that in the middle, there is a sudden increase according to by SEP event. So you can see that there is it is also well known there is a high correlation between the neutron monitor and the proton flux data from satellite. So this shows the solar activity event till the last September. Actually, there are huge event, total 56 times. At that time, we have captured the data like this. The first one is the safety system result. Actually, you can see that September 11th, the Korean error, the 081, 085 flight route, the cosmic radiation dose increased to 215 microsievert. Actually, comparing the usual situation about the 80 microsievert increase. And the right upper side, you have captured the neutron monitor data, which is the OLU instrument, and the below one is the GOES proton flux data. Actually, there must be high correlation. And the last one is neutron monitor in Jang station in Korea, in Antarctic. Actually, there is 2 CMEs, September 4 and September 6, and it caused the published decrease during 3 days. And finally, there was a GLE 72 on September 11th. Actually, we have captured this kind of the change successfully. Okay, this is a summary. Korean Space Weather Center is the regional one in centers and provides space weather forecasting service based on the observation and prediction model result. And to increase the reliability and accuracy of our forecast, we are going to verify the forecast result as WMO recommended method and verify the prediction model result by comparing with the real measured data. Finally, to elevate the high-level attention on the public users or space weathers, we think that the extent public awareness of the risk of space weather is important. Actually, the further discussion will be continued in the panel discussion. Okay. Thank you.
So last but not least, we have Space Weather Forecasting Operational Needs, a view from NOAA STFC by Biesecker.
All right, and the key point of this is a view from NOAA STFC, which is not the same as the view from NOAA STFC, because when you ask me to give a talk, you get my opinion, whether you like it or not. Much like, so I would say much like Pete Riley finished the morning session with a pragmatic view of forecasting BZ. This is my pragmatic view of forecasting, and I think it's important to talk. If you want to talk about improving forecasting, you have to know how forecasting happens, and so that's actually probably the bulk of my talk, is just making sure you all kind of know how we do things at NOAA. So the basic forecast goes out twice a day, just after midnight and noon, universal time, and these are typically a probabilistic forecast. And so I've given some examples of those probabilistic forecasts for the solar proton or / radiation storm forecast and the solar flare forecast. And of course, I picked the September timeframe forecasts when we had all that nice space weather activity. We also do that for geomagnetic storms, but for geomagnetic storms, we also do deterministic forecasts. So here's our probabilistic forecast for the next 3 days. These happen to be the recent period, just last week, for geomagnetic storming activity. And then this was the deterministic forecast, where the forecasters actually enter a KP value for every 3-hour period, so 8 periods a day for the next 3 days. And I want to make the point about probabilistic and deterministic, not because it's the most important one. In fact, my co-authors don't agree with me on this point, at least not all of them. But when you look at the difference between the way we forecast geomagnetic storms versus solar radiation and radio blackout storms, to me the main difference is that we have deterministic forecasts. So when we issue forecasts, also reissue watches, warnings, and alerts when activity is occurring. A watch is telling us that conditions for the described event, be that well, we don't do a watch for flares, but the possibilities for a geomagnetic storm are favorable, and we associate this with long lead time but lower accuracy, typically larger than 1 day. In fact, our basic measure, our Government Performance Records Act, is for forecasts greater than 1 day. And so this was the forecast we put out last week, where we put out a watch for geomagnetic storming of G2 levels on December 4th and 5th, with G1 on the 6th. And then later you can ideally give a warning. So conditions are likely, or really they're about to happen, usually associated with shorter lead time. In the case of a geomagnetic storm, that's typically an hour at most, and often quite less. And so here's the warning that we put out last week for G1 storm onset. And then the alert is telling us that the event is actually underway. Space weather conditions are disturbed at Earth, and we're feeling the effects. You might call this situational awareness, and of course there's the alert we put out following the watch, warning, and alert for that event. And these of course all relate to the space weather scales, which I'm pretty sure most people are familiar with. But if you look at the radio blackout scale, we don't issue any watches or warnings related to flares. We only issue alerts. For solar radiation storms, there's no watch that we issue, but sometimes we can give warning, and we always give an alert. And for geomagnetic storms, we can do all three, watch, warning, and alert. And to me, of course, the main difference is driven by the time scale of the events. a flare is happening as soon as we see it. Protons take a little while to get here, and of course, CMEs move out ponderously slow at, a few hundred to 1,000 kilometers per second. So how do we get from here to there? Well, what is there? And I'm going to use an example that is relevant, if not yet finalized. But, if we wanted to give flare forecasts that give a watch or a warning, do we need to move to deterministic forecasts? Well, can we even forecast a flare before it erupts? And I think the answer to that is still no. We can do it probabilistically, but here's my issue with probabilistic. If you look at what ICAO, the International Civil Aviation Organization, is putting together, they're looking to have forecasts for the next 24 hours in each 6-hour window for flares of a given threshold. And right now, we would give them the same number for all 4 periods. And so the flare might well occur in one of those periods, but if it doesn't occur in the other 3, your verification statistics are going to be terrible, and the customer is not going to be very happy. So we need to get the sort of fidelity to forecast flares in that sort of time span. And, how do we get there? I don't know. There was some hope, and maybe there still is, that helioseismology can tell us about what's coming up. This was some work done looking at the helicity underneath active regions, but all subsequent studies have really failed to come up with as positive a result here. But do we need to look underneath the surface of the sun to be able to forecast flares more than a day in advance? With proton events, again, there's no watch. What would we need? Well, again, we'd want to be able to forecast a specific intensity. Again, we can look at ICAO's requirements, and again, they're looking for a forecast window of 6 hours, 12, 18, and 24 hours into the future. And what can we say about that in a quantitative way? Now, of course, we need to know that a flare or CME, and I'm not going to get into that argument, will erupt as a function of location and the ability to generate a proton event. And I would argue we're a long way from that. And then, of course, to tell the aviation folks what they need, you need a good radiation model to tell them what they're going to see at aviation altitudes. There are some instances where you're not well connected. This is some stereo and GOES data for proton events showing that when you're well connected, you get a nice prompt rise at the spacecraft. When you're not well connected, there's a delay. But also we see that if you look at the proton flux as a function of longitude away from the source region, if you detect it first at one source location, you could potentially forecast what fluxes you will see far from the event source location. Geomagnetic storms, our current accuracy in predicting a G1 or greater 1 day in advance or more is 65% as of a couple of months ago. But that's for all solar wind sources, including CIRs, high-speed streams. We'd like to be able to have more lead time than the less than 24 hours that we would get for an extreme event that's ICME driven. And we'd like to be able to issue warnings with more lead time and or with the location of the customer in mind. So in this case, sub L1, but as Joe Borowski recently put in the ACE News, this is background solar wind, the size of the structures in the wind. This is the size of the cross-section of the Earth's magnetosphere and bow shock. This is the orbit of the ACE spacecraft, and you can see that ACE may not even be sampling the same solar wind flex tube that's encountering the Earth. This doesn't necessarily apply to CIRs or ICMEs, but it's something we have to keep in mind. Another way to improve it is to move to regional warnings, and this is a plot from our geospace model that was introduced about a year ago, giving us the ability to not forecast a single number for the whole globe, but to tell a customer that the impacts are going to be over the northeast of the US and it's going to be all quiet in the southwest. There's a lot of other things that we need to be able to do. I didn't mention the ionosphere or the satellite environment. Irfan mentioned data assimilation. I'm a big fan of moving in that direction. Observe Aussies and Aussies. Determining the value of future and or existing observations is important to do. And of course, as Pete said, we can't do that last one yet. And to answer the question we got asked, what do we need to do? Well, the risk register and swarm won't sustain us forever. First of all, we have to keep reminding those that are responsible for budgets and giving us our funding of the need. They won't always remember. There will always be new people coming in that haven't heard the message. If we stop asking, they'll think we don't care, and they'll start to give the money to somebody else, I would argue. And to me, swarm and swap, and we saw this a little bit with the economic studies that were being done. They weren't totally about extreme activity. They included moderate activity, but what about everyday space weather? And I say we need to sell that. That may not be true. Maybe like tsunamis, we're a once every 10 years extreme event kind of thing. Maybe we have economic value on a daily basis. Let's try to quantify that. So that's all I had to say.
Thank you, Doug. So if you can ask all panelists to make their way up onto the podium, please, and I'm going to hand over to my co-convener and co-chair, Antti Pulkkinen.
You spilled water all over. That's all.
Oh, I did. I'm sorry. I'll sit there.
Okay, so we're moving to the Q&A part of the panel. I will have a kickoff question that I will ask all the panelists to address first. And once we're through that round, then it's open for the audience to join the discussion, have questions, comments, ideas, everything is welcomed. We don't have microphones here for the audience, so when you speak, I ask you to speak up so that everybody can hear the question. And also, please introduce yourself before your comment or question. So with that, I would like to kind of maybe build on the economic discussion we had earlier this morning and the presentations from Stacy and Mark, and maybe a similar question I asked from Stacy is that how strong do you think is the economic case for potential space weather impacts to date? We've seen increasing number of these studies coming from various organizations. Are we there yet? And if not, what as a space weather community meaning the scientists, engineers, and operators, we can do to help improve our understanding of the economic impact and significance of space weather? So it's a kind of a two-part question. Doug, why don't we start with you since you're there at the end?
All right. So I think Stacy answered that question herself this morning. I think she was quoting Ed Otten when she said that our economic studies are in their infancy. We are just, so I think the clear answer is we haven't made the economic argument yet. I mean, the error bars on what Stacy showed and what Mark showed, are huge, and the assumptions are still untested. So there's a lot of really good work happening, and I think they have established a really, really good start and a framework that we can build on. But I think it's very clear the economic argument isn't one you can necessarily take to policymakers and not have holes shot through it at this point.
Elsayed, let's go through the whole panel.
I would agree that there's still a lot of work that needs to be done to make it make it a solid case that where policy can be made on top of those numbers. But I would add that I'm optimistic about that, because we've had a kind of a steady drum of awareness of space weather in the last 5 years, really, and I think that's born out of these first blush studies that were done, back in the early 2000s about what would happen with a Carrington type event, et cetera. And I think that going forward, the key is that the agencies as well as the community really needs to speak with one voice about a set of priorities for space weather. I think that if the case is going to be made, it needs to be made coherently and in an organized fashion. Otherwise, you can pick and choose which argument you believe in. So that's something that I think that as a community and as agencies, both domestically and internationally, we should come to a set of priorities and agreements. And I think that discussion is starting in different international forums.
Okay, so I'll build upon the previous two comments that yes, we have gotten a good start on making an economic case for space weather impacts. I mean, we could say that we have done a sort of a first order study. There's certainly a lot more needs to be done, as Doug mentioned. And I was also very happy to see Stacy's talk that we are also looking at those more frequent but low, not extreme or high impact events. We're also looking at these, weaker events, but that happen more frequently. So if you look at the previous studies on the economic impact, that the one that was done by, let's say, the Lloyds that looked at the power industry that came out in 2013, and then there was a study by Cambridge University, and then they've all sort of focused on some sort of certain events and focused on extreme events. But if you look at systems, they are going to be stressed day in and day out if there's going to be space weather. So over time, they will be stressed, and we really need to roll into the economic impact of what happens when you have systems that are stressed over time due to space weather events. So we all, as I mentioned in my presentation, that we really need to look at the sort of a day-to-day space weather events also.
In addition to the presentation of my talk, I would like to add more on the Chinese space weather investment. With the years of economical growth in the 10% range, China has been rapidly climbing the ranks of the top economies. So in 2010, China became the second largest economy in the world. However, the GDP growth is only about 6.7 in 2016. So the growth rate gradually slowed down, and the downward pressure on the economy is relatively large. During the period of 2010 to 2015, this is a 12th five-year period in China. This space weather investment is about 1.5 billion RMB, or equivalently 200 million US dollars, which is a very small portion of the GDP. However, China is paying more attention to space research from the top level And this is good news for us. For example, the Chinese President Xi passed a very important message in the Chinese Science and Technology Conference. He said, we must promote the integrated development of space science, space technology, and the space application. As you know, space weather is crucial to space activities. Even though China suffered the slowdown of economy, but we are still expecting 3 billion RMB in the next 5 years from 2016 to 2020. That means we double the investment of this space weather in China. Thank you.
I was really impressed by the work that Stacy done and presented. I think there is a step forward, and it has much more credibility than what I have ever saw before. And she actually mentioned that there is a lot of uncertainties, and so we need to quantify these uncertainties. And we need now, and what I mentioned in my talk, that economic impact is the most always at the end of the chain that started at the sun, where the space weather originated. And these uncertainties are accumulating, whether we want to predict space weather or predict the sort of medium impact of moderate event or impact of severe event. So it means that quantifying this uncertainty is the task not only for economists at the end, but also for all our scientists. And again, we need to work together to really come up with credible numbers.
Okay. I think I think that the most important thing in the space weather part most people are not familiar with the space weather environment. That I think that that's the most important thing which we have to solve, I think, including the economic case. Anyway, a few years ago, the Lloyd, the insurance company, reported the city index by solar storm. Anyway, at the report, the Seoul was ranked 7th, the most dangerous city by the severe solar storm, and they estimated the total the amount of damage will be the $1 billion in Seoul by the solar storms, like the Carrington event. So, but most people are not interested in such a report. So, and actually the economic case in this report means that the economic case is not strong for the space weather impact. Anyway, as I mentioned in my presentation, the most important thing we have to promote the space weather risk is the risk and disaster. So after that, we can get the more investment from our government, something like that. So yes, I think that we have to impress on the general user the space weather is a very severe phenomenon, like the earthquake, something like that. Okay.
Okay, thank you. And now at this point, I'd like to open the floor for the audience, questions, comments. Terry wants to go first. Of course. Yes.
Could you repeat that, please? Could you repeat that, please?
I think like teacher actually, I don't think the economic impact information is sufficient. I think we need to be able to show that we can actually do something that improves the situation. Now, for example, the power grid, power companies, they have a set of standard operating procedures for things that they do when a storm is coming. We need to find some way to work with them to find out what we can do so that they're actually able to make better decisions during that process, so that we can actually make an economic benefit, not just show that there are potential impacts. And I think one of the most important things that Stacy's study did was show that industry is interested in working with us. So I guess I'll ask the question, what ways do you foresee that we could pull industry in as partners so that when we're working on space weather applications, we're actually doing things that are directed towards what they need to make better decisions?
How can we bring industry and end users to be part of the communications? Who wants to go first?
Go ahead. Actually, Antti would be a good person to answer this, because that's exactly what he did in the first LWS Institute, where he pulled industry and other stakeholders and partners together to really get at what is needed for them to develop a process for dealing with GICs, geomagnetically induced currents. I think but I want to go back to the question posed. The question posed was, is the case strong enough compared to the investment requested? It depends on what we're requesting. In that sense, what you're talking about is kind of a refinement of what type of information and the interaction we have with the industry. But I think the question is whether, and that's driven by making a case to them that you need to make those decisions. And so that's where, rather than ignore them and then, et cetera. So I think the next step of these economic studies will really show, where the vulnerabilities are, and then that's the conversation that will be easier to have with industry in that sense.
But I agree with Terry that we really need to engage the industry when we are developing the economic case. Otherwise, we're going to get in the situation like when the risk study came out from Cambridge University. Right after that, the power industry in the UK came out and say, no, the impact is not so much great. There's going to be degradation in the service, but not a disruption. So we really need to work with the industry partners, make sure that that we are able to communicate to them exactly what are the impacts and develop processes that can be put in place for their operations.
Doug?
Yeah, so I think engaging customers, there's not one size fits all. It's going to have to be a multi-pronged approach. And, I might argue that the power grid was almost the low-hanging fruit because it was a very engaged, knowledgeable community that we already had lines of communication with. You don't always have those lines of communication, and maybe they don't always want to share that information, but Stacy said sometimes it's how you engage in the conversation with the customer. Don't just say, I need your data, ask them how their day is. How are they doing? No, I don't know, I'm not the best at that kind of relationship necessarily, but maybe it is the way we communicate with customers that has to change, and that'll work in some ways. Another thing I've heard in the last year from a commercial service provider who is talking to customers in a certain industry area, in this case it's satellites, that person feels that they've been able to get a lot more information because they are also in the industry, they're not the government, and they've been able to get a lot of information because of that. And so whether it's via commercial service providers or from the way we talk to customers or low-hanging fruit or other ways, I think we just have to try all of those as appropriate.
Masha?
I just want sort of to switch from gear from power industry to satellites because that's what relevant to NASA and our expertise. And at NASA we're working, scientists working closely, start working very closely to mission operators, and especially, for example, we're working now with a flight dynamic facility, and they have very special need is collision avoidance. And satellite collisions can give us a lot of, economic loss. And so we want to understand what we can do now with our capability now so they can have a big impact. And I was really surprised, just by working with them. That's why I'm always emphasizing it's important to work together, to start talking the same language, that they are not really asking for very accurate models, an accurate prediction where the satellite but the most reliable error bar. Even if error bars, sort of area of uncertainty, it's big, but they know that it's very reliable. It will help to avoid, collisions. So I think similar, things is when we're working with mission operators concerning the satellite functions.
Gee.
In order to meet the needs of the end customer, I think the very important link is we need to study the effect of the space weather. Right now, as our community pay more attention to the space weather science, from the research to the operation, to predict the space weather. However, we haven't paid enough attention to the effect of the space weather, to the power, to the satellite industry. I think in the future, we need to change this, to improve these situations.
Okay, when actually in Korea, I talk about in case the Korea perspective. Actually, in Korea, our center inspect whether there is any impact in industry when there is a 3 or 4 level solar event. Sometimes, usually the company side doesn't. I think that they do not want to offer there is any impact in their system because I think that they understand. That's my guess. Actually, they understand that if there is any impact in their system, it means that there is some defect in their system. So I think that at the point of view, we need to more communications about the space weather environment in the impact, so to solve such a problem and issue. So, yeah.
All right, thank you. And since there was a lot of comments about the end users and engaging the industry, I'm going to do something unorthodox here. I'm going to actually call on Bob Arrett specifically to comment. Bob is from Electric Power Research Institute. So I'm actually curious to hear from all this discussion in the earlier morning presentations from the power engineering or power industry standpoint. Do you see there's a good case from the economic standpoint? And with that also, how can our community here better engage the industry to work on this? Okay. Can you speak up a little bit?
collaboration that we have and what it is
Thanks, Bob. Okay, other questions? Next question. Yes, sir.
Most discussion was about day-to-day, Alexander Kakovich at New Jersey Institute of Technology. Most discussion was about day-to-day space weather forecasting. And I think what is missing is the forecasting, long-term forecasting. I mean, long-term on scale of solar cycles. And Doc mentioned that every day space weather is called space climate. And we see now that on the sun we see big changes. We discussed this on Monday, big changes in magnetic field. Also by heavy seismology, they show that there will be some big difference in the next solar cycle. And the economic impact of long-term changes is much bigger than economic impact of extreme events. It's well known. So my question is to what agencies, NSF and NASA, are planning to do in terms of developing understanding, forecasting of space climate on scale of solar cycles.
Who wants to go first? Elsayed?
Sure. I mean, NASA does fund and has an active research program in solar physics, and that includes kind of the interior modeling that that would predict kind of solar cycles. But I think any modeler would say that we're a long ways off from being able to predict accurately the next solar cycle, much less several cycles forward, as evidenced by this past solar cycle. I think we are working with NOAA and others to start up the next working group for solar cycle prediction for the next solar cycle. But certainly it's part of our competitive research program, and we are flying. We have instrumentation on SDO. And then other complementary instrumentation that address that topic, but it is certainly a active and very nascent area of capability right now. Active area of research and nascent area of capability for being able to predict that.
Yeah, so for those that don't know, I chaired the Solar Cycle 24 prediction panel, and so I'll speak from that perspective. And of course, right, one of the issues with predicting the solar cycle is it's very hard to do, and to give a customer a prediction that you have confidence in, 5 to 10 years into the future, we're still trying to come to grips with. I would say the industry areas, there's a lot of industry areas that are at least interested in knowing, and ones that we know take action. Primarily that would be folks that are going to be flying satellites want to know. They're putting that into their mission design and their planning. But EPRI, the Electric Power Research Institute, when we released the forecast for Cycle 24, contacted me and said, hey, can you tell us how many geomagnetic storms you're going to have now? And that's a whole nother level of uncertainty that goes beyond predicting the sunspot number. And so to provide the customer with that actionable sort of information, I would argue we're pretty far from, and how much would I expect out of the power industry in response to that? I'm not really sure.
The satellite launching or the lifetime satellite depends on height of Earth's atmosphere.
Right.
And that correlates the solar cycle, and this is a multi-billion-dollar impact.
Yeah, and right. So satellites is the main area where we see that, and they can live with a basic forecast of sunspot number, which correlates highly with F10, and I'm not going to get into that in detail, but maybe good enough for them, for the kinds of planning they're doing, if we can do it accurately enough, and what defines accurately enough.
Okay, let me just speak from the NSF perspective, and we are sort of in the same situation as NASA, that we do have an extensive, or we have a robust research program that is looking at variations in the solar or space climate, as you call it. Space weather at NSF is the activities at NSF that relate to space weather happens across different directorates. So not only in geosciences, but there's also space weather research is being funded from the Directorate of Mathematical and Physical Sciences, Astronomy and Astrophysics Division. And we also support active research activity at the National Center for Atmospheric Research, looking at those type of questions. What happened? Well, can we predict the solar cycle variability?
Anybody else comments on the significance of space climate? No? Okay, next question. Dan, I saw your hand up earlier. You're just yelling. Okay. Questions? Mark.
I just wonder how see we moved from the current situation where we've got space-based very much about national programs that we're trying to work together, but we really need to move to sort of an integrated global setting. I just wonder how the panel sees moving there. Arguably, ICAO, of course, in forecasting into working in a more coordinated manner, but this is global risk we need to be looking at globally. How do we transition from where we are now to a more joined up sort of international effort?
International collaboration. Let's go first.
This may be a good opportunity to discuss what's happening in the UN Committee for Peaceful Uses of Outer Space, where there's a current drive right now to put together a framework for space weather services, and that's under their Unispace Plus 50, like the 50-year anniversary of UN COPUS. One of the thematic priorities is to set up a framework for space weather services, international space weather services, and so representatives from the different members of UN COPUS have formed a space weather expert group that has defined kind of next steps for getting the international cooperation coordination needed across kind of the different organizations that are currently doing kind of niche efforts. You have COSPAR, ILWS with kind of the science, overall science picture and science need. You have ICAO from civil aviation coordinating some of the space weather activities there. And then also you have ICIS, the international group of space weather prediction centers, essentially. And so kind of coordinating across those to get a bigger picture of where they fit in together in that framework. So I think that effort is beginning, but there will be a plan put in place, or a plan put forward for proposal to the UN COPUS next year regarding kind of setting up this framework. And I'll invite Terry and a few other people, and then Herman, who were helping write this plan, to comment if I correct or elaborate.
Maybe Masha, you're in your role for the COSPAR Space with the League, and seems to have been doing a lot of international work. So I'm curious about your thoughts about the international collaboration and how can we take this to the next level?
Yeah, again, my talk was mostly dedicated to that, and my main point was that services, there is a lot of progress have been done thanks to ISIS to coordinate services, and there are more work is on the way. But I want to emphasize the total investments that we are doing into services, and just qualifications to do services, and the qualifications required to do research, plan mission, how much money need to send mission, it's a lot of investment, and we need to do much more in that to maximize return on investment. Again, from the top down, as COSPAR organization who really don't have funds and don't funding opportunities, but what we're trying to do to provide a platform where isolated groups that's already now funded to do, but internationally there is a lot of groups that funded to do basically the same thing, and they can come together and do things much more efficiently and maximize return on investment. Of course, concerning mission, it's even more important. And again, when we're planning mission, it's important also have a balance and not get into the trap that is research mission, that is operation missions. We just cannot afford to have only operation missions. But again, it's not for me to really to make that decision because that is money. But what COSPAR can do, we can provide input that, scientists can provide input to policymakers what is scientifically valuable and that can be taken into account or not. So what I'm sort of trying to lead the COSPAR community, space weather part of the COSPAR community, to form global community hub to work, for us to work together, be very inviting, but also form global community voice that based on expertise.
Yeah, Choi.
So as everybody understands the importance of the international collaboration in the space weather, and we have been talking about the international collaborations in different international organizations, such as ILWS, the SCOSTEP, the EASWay, the COSPAR, the WMO. We have already been talking about this many times, and I think it's important to step forward. We need a real international collaboration, not only limited to the virtual collaboration. So that's why we proposed to set up the global space weather monitoring network, the global space weather information network, and the global space weather forecast network. As a step, we would like to call for the International Meridian Circle Project. I think we should work together. We need the real investment from different agencies worldwide. I don't think we are only talking about international collaboration on the paperwork. We need a real investment. This is my point.
Thank you. And since I think Herman, you were mentioned here, and you've been very active in this, international activities. You know some of the challenges and advances that we've made over the years. So I mean, maybe you could share your thoughts on this international collaboration. How can we take it to the next level?
Well, I can only reiterate what Masha said. We are, and we have a similar panel discussion. We are still in a toddler phase of the life in general, and therefore it must be an iterative process of improving science understanding, improving modeling, and you cannot just, as much as that has, define at this moment what we have just to live along.
Thanks, Herman. Yes, please.
I mean, the quick answer is as soon as possible. But we wanted to get input from the community, so we had an RFI, a request for information process, where we got a lot of good feedback from the community about different ideas about both of what the centers could encompass in terms of topic and also process and infrastructure that the centers could have. We are currently, we had an internal kind of review of that input at NASA, and we are planning to meet with NSF next week, and that's where we are in the process. So we hope to have a solicitation out beginning of next year, but the idea is to get it out as soon as possible.
Yeah, please.
I would like to ask, don't forget about solar interiors, because it looks like solar interiors eliminated from all topics. And, but it is critical for understanding space weather and build reliable forecasts and understand really what kind of phenomena we deal with, not just measurements of just measurements from seas, but it is very important to understand the reason why, for example, such storms were happened in this moment of time, in this place.
Irfan, you want to comment that?
Thank you.
I'll just mention that, yes, at least at NSF, yes, we have not forgotten that. If you look at NSF's investment in Gong, that demonstrate that we are certainly cognizant of the importance of solar helioseismology in the space weather enterprise. So that investment is front and center, and then we're going to continue to support solar interior research.
Okay. Jeff.
Jeff Newmark from Goddard. I have sort of a half question, half comment, and it relates to interacting with the defense side of the space weather and how it can help more of us, the civil side. And I know it's always a difficult way to get into them, but they have a tremendous, of course, database of data producing satellite behavior and satellite effects on space weather. And in my previous discussions with them, they're actually more, at least from the government to government side, very open with some of that information, and how to utilize that, and can we utilize that, or should we be pushing harder? Maybe it is happening, even as part of my question, to then bring that onto the civil side. And again, I didn't read Stacey's report yet. I'm very interested in seeing where she's, pulling in information from industry really hard, because that's there. As said, it's, satellites don't get anyone to get a defect. So, but the Defense Department will talk about some of that. And I just want to know, is that, I know in theory it's happening, but is it happening in practice, and can we make it better?
We can certainly make it better, it is happening in practice. The communications are happening in practice, and there have been some successes, or at least one success in getting for instance, the GPS particle data out. That's the type of thing we'd like to see across the spectrum in terms of measurements that are made with defense satellites or national assets like that. But that's the communications are happening. I can only say that we're trying to engage them more in our research program through, for instance, Living with the Star. Now that we have the advisory group set up, program analysis group set up, that they're going to be members. Representatives from DoD are going to be members. There is also the challenge that they are. If the MSP is not going to continue, so some of the space weather sensors that community has relied on for a number of years are not going to be there, and so how we're going to replace that, and then also what's going to happen to that data set. That's something that's certainly NSF and NASA have been broached by members of the community about, and we're going to try to figure that out. But to answer your question, it's still a work in progress, I would say. I don't think we've come up with any one solution or any way to it's got to be topic by topic.
Yeah, and I'm sure many people in the room are aware, I mean, the swarm and swap activities, the DoD has been a major partner in many of the actions. There really is a lot of engagement, at least agency to agency. And certainly we work with the DoD in quite a lot of levels in various areas, both on forecasting, but what's the future of their radio and solar optical networks, and what's the best way to move forward with that. So there's quite a lot happening, and yes, it's always the thing. How do you weigh the needs of one versus the other? Who pays for one or the other? Lots of big questions and issues that always have to be resolved.
And now that we heard the U.S. perspective, maybe Choi and Jang, so if you could comment, with your relationship with your departments of defense, and if you have an information exchange going with the military side of the panel.
Sure. Actually, our center is a government agency, and we are collaborating with the Air Force in Korea. But actually, they are very interested in the space weather anyway. But in case of Korea, they do not have enough information to provide us. They just want to get information or data from us at this point. So anyway, we are keep collaboration with our force and to find such a useful information about the space weather environment. But anyway, at this point, there is not enough data or information from our defense side, I think. And in addition, usually our Air Force or defense side does not want to open their system or situation. It's a secret, something like that. So that's one of our difficulty to co-work with our defense side. Okay, thank you.
In China, we don't much information exchange with the Defense Department, but they do very interesting in the space weather. They approach us for the observational data, for the modeling, the products, but we don't have much information from them.
Okay, thank you. Looking at my watch, and this thing is going to turn red now. Okay, good timing, huh? So with that, we'll close the panel. So why don't we give a big round of applause for the panel? And Mario will have the final word here.
So I just want to firstly try to sum up, I think, the main core of the discussions. And Herman is right, we kind of ended up with a very similar end during the European Space Weather Week panel, and that's all about communication. And scientists are good at communicating with scientists, and maybe we need to be better at communicating with everybody else that we need the information from to improve all the elements of space weather, from the science to the forecasting to the end user needs to what products they really need and what we need to do to provide those products. Also, clearly, some places, some countries, some organizations need to have better communications internally and between different departments and different agencies. Some of that is really happening, some of that is coming together quite nicely, and there's probably still improvements to be made there as well. And one of the things that I was hoping the panel would have touched on, but we didn't really get there, and that's the really decisions between where the funding goes versus what you need in terms of new data and what you need in terms of new models, and how you sort of prioritize one or the other to make the real improvements. So maybe something to think about for a future panel if we carry on the session for a fourth time next year, which we may or we may not. So thank you all for staying around. Thank you to all the speakers, all those that have posters, all the panelists, and to my co-chairs and my co-conveners, and thanks again.